Hi guys, today I am discussing about the subject switching theory and logic designs. In this STLE subject, I am discussing about the topic sequential circuits. This is presented by GVS Amananda Reddy with registered roll number 24BQ 1A0436. In this sequential circuits, I am discussing about the topic flip-flops. What is mean by flip-flops? A flip-flop is a 1-bit digital memory circuit that is fundamental building block of sequential circuit. It stores data and has two stable states, that is 0 and 1, maintaining its current state until triggered by an input or clock signals. There are and in these flip-flops there are some types of flip-flops. First one is SR flip-flops. Second one is JK flip-flops. Third one is D flip-flops. This is also known as data flip-flops. And last one is T flip-flop. Our other name is toggle flip-flops. Now we are discussing the SR flip-flop using NAR gate. NOR gate. An SR flip-flop is specially a gated or clocked SR flip-flop. Can be constructed using a basic SR latch made of two cross-coupled NOR gates and two additional AND gates for clock control. Now here the inputs, now the NOR gates are, for the circuit diagram, NOR gates are cross coupled and the inputs are R and S, and Q1 Q bar are outputs. Now the logic, this is the logic diagram for SR flip flop using NOR gate. Now truth table of SR flip flop is SR is equal to 1 0, then Q1 Q bar 1 0. 0 0 is 1 0, 0 1 is 0 1, 0 0 0 1, 1 1 0 1. Now SR flip flop using NAND gate. An SR flip flop is made using 4 NAND gates, 2 2 from basic cross couple latch and 2 more at the input stage to add the clock control. The S and R inputs analog with a clock pulse and fed into the two input NAND gates. The outputs of these input gates are then fed into the cross-coupled NAND gates, which from the memory element of the flip-flop. The circuit is configured by configured such that outputs change only when the clock signal is high and S and R have valid input combination. Here, two NAND gates are cross-coupled, then inputs are S and R, then the outputs is Q1 Q bar. This is for the logic diagram for NAND gates. The now the truth table is SR is equal to 1 0, SR and Q1 Q bar is 1 0 for 0 and 1, 1 1 for 0 1, 0 1 is 1 0, 1 1 1 0, 0 and 0 1 1. Here, two NAND gates are cross coupled to each other and attached to the another two NAND gates. The logic symbol is S and R, and the outputs are Q1 Q bar. Now here the S and S bar is inputs. Qn is the present state. Qn plus 1 is next state. 0 0 0 is the next state is 0. 0 0 1 for the next state is 1. 0 1 0, the next state is 0. 0 1 1, the next state is 0. 1 0 0, the next state is 1. 1 0 1, the next state is 1. 1 1 0 is for undetermined. It is here 1 1 0, the next state is don't care. 1 1 1 for next state is don't care. Here 0 and 1 are doesn't change. When we comes to the 0 0, the next state is reset. The next state of when the output is 1, it will be set and it will be now here the excitation table. Q Qn plus 1 S and R. 0 0 for 0 and don't care. 0 1 for 1 0. 1 0 for 0 and 1. 1 1 for don't care and 0. Now we are moving to the another flip flop. This is known as JK flip flop. A JK flip flop is fundamental type of sequential logic circuit and a digital memory device that used to store a single bit of binary data. It is an improvement of over the SR flip flop because it eliminates the problematic, invalid, or intermediate outputs. States at, that occurs when the both inputs are high. The J and K inputs act as set and reset signals respectively. Here the circuit logical symbol for JK flip flop. J and K are inputs, Q1, Q bar are outputs. Here, two NAND gates are coupled to each other, and, and the NAND gates are further attached to J and K. The J is attached to the J is attached to the Q bar, and the K bar is attached to the Q. The characteristic table for JK flip flop. Here, 0 0 are the inputs, and the clock is on state. The Q1 Q bar is 0 and 1, 1 and 0. The next state is 0 1 and 1 0. 0 and 1 for present state is 0 1 1 0. The next state is 0 1 and 0 0. 1 0 for 0 1 and 1 0. The next state is 1 0 1 0. 1 1 0 1 and 1 0. The next state is 1 0 and 0 1. The excitation table for JK flip flops. 0 0 is Qn, 0 1 is sorry D flip flop is another type of flip flop. A D flip flop is a digital circuit that stores a single bit of data. It's also known as a delay flip flop because it delays the input data until the next clock pulse. The flip flop has data D input and clock input and two outputs Q1 Q bar is complement. The output Q takes the value of D input when the clock signal transmitted from the low to high or high to low depending upon the design and holds that the value until the next active clock edge. Here is the block diagram of D flip flop. Q is the input, Q and Q bar are outputs. Here the circuit diagram for D flip flop. Two NAND gates are cross-coupled to each other and further attached to the NAND gates, and the D is attached to the another flip flop, and clock is enabled. The outputs are Q and Q bar. The characteristics table for D flip flop is is Q is current, D Qn plus 1 next state. 0 0 for D, 0 1 for 1, 1 0 for 0, 1 1 for 0. Here D is equal to Qn plus 1. The last flip-flop is known as T flip-flop or toggle flip-flop. A T flip-flop is a clocked digital circuit that toggles its output to the output state when the T input is 1 and holds the current state when the T input is 0. The T stands for toggle and it's often used in counters and control systems. Here the block diagram of T flip-flops. T as input, Q and Q bar are outputs. Here is the circuit diagram. This is known as the circuit diagram of T flip-flops. The the characteristic table of T flip-flop is T is equal to 0, Qn is equal to 0, then Qn plus 1 is 0. T is equal to 0, Qn is equal to 1, then Qn plus 1 is 1. T is equal to 1, Qn is equal to 0, Qn plus 1 is 1. T is equal to 1, Qn is equal to 1, then Qn plus 1 is 0. The excitation table for T flip-flop is Qn plus 1 T. 0 0 for 0, 0 1 for 1, 1 0 for 1, 1 1 for 0. Thank you. That's all for the topic for the flip-flops.